สวัสดีครับผมชื่อปรินทพัฒน์เพ็งพันธ์กำลังเรียนอยู่ที่โรงเรียนนานาชาติคริสเตียนกรุงเทพศึกษาอยู่ชั้นม .4 ครับวันนี้ผมจะมานำส่งการบ้านคุณครูซึ่งเป็นการแบ่งกลุ่มกีฬาสีด้วย Genetic Algorithm ครับ
Hello, so before we get into the explanation of the genetic algorithm, first let me explain the goal of this. The goal of this is that an organization is trying to organize a team color event in order to boost the relationships within the organization. Therefore, with the dataset given, the dataset has gender, department, weight, height, and age. Now, in order to make the competition fair and also encourage the people within the organization to form relationships, many things must be taken into consideration. Namely, the genetic algorithm takes into consideration the gender difference, the BMI difference in order to ensure that there's the same amount of athletic people in each department, and the department difference in order to ensure that people in each department are spread into the two colors evenly, and the age difference. Now let's take a look at the app itself. So on the left side, you can see that we can configure the running parameters. These parameters include the population number of generations to run, and the weight. What I want to focus on here are the weights. So you can select from a few weights. First of all, the one that prefers gender, department, BMI, and age. As the name describes, the ones that prefer gender will prefer splitting the gender amongst the two team colors as much as possible, while the second one will prefer splitting each department into two colors as evenly as possible, and the third one and the fourth one as the name describes. So now let's select this one and start running our algorithm. So as you can see here, it will show the generation that is running as well as the fitness value or the loss value, which the lower the better. As the model is running, I also want to describe the BMI, the statistics. The first table is the BMI distribution, where the purple bars are the first group and the orange bars are the second group. Second table describes the gender within each group. You can see male, female. Third table describes the department within each group. The fourth table describes the age distribution. And the fifth table, describes the people within each group. So let's give this model some time to run, and then we'll come back to look at the results. Now, after 150 generations, we can see that the model has kind of stopped at the loss value of 32. So let's look at the graphs. The BMI distribution is kind of similar. As you can see, most of them are almost identical, which ensures a fair composition of athletic and non-athletic people. But the gender here, as you can see, is not exactly equal. The reason for this is that this specific weight will prefer trying to distribute the amount of people in each department. So as you can see here, Department D, which has the most people, are distributed at exactly the equal point. So both people in Group 0 and Group 1 have the same amount of people from Department D. And as you can see, there aren't many spikes, the people who are in just one department. So you can see right here. The age distribution for this is also fairly similar. And as you can see, one of the most interesting things in here, or one of the most important things, is that the people in both colors have to be the same. So as you can see here, the people in both colors are the same. So this is it for our first model that we'll be looking at. And now let's take a look at the second model. So now let's take a look at the second weight. This weight would prefer splitting out the gender evenly. So that means that group 0 will have the same amount of male as the males in group 1. And that goes the same for females. So without further ado, let's start the evolution. Alright, now the model has finished running, and after 150 generations, these are the results. So as you can see, the first result is the BMI distribution. This is not too far apart from the first weight that we looked at. So the BMI distribution is roughly similar, albeit this one is a little bit disproportionate. However, the notable feature of this model, as talked about earlier, is that it allocates the same amount of males to group 0 and group 1 as well as the female. Now let's take a look at the department. By allocating the same amount of males and females for each group, it compromises in the allocation of the departments. So as you can see, there is a skewed distribution here. So there are 37 for group 1 and 35 for group 0. Not too bad. However, you can see in the department R, there are 16 people in group 0 and 7 people in group 1. For department J, there are 9 people in group 0 and 20 people in group 1. So this is the drawback of using this weight. Now this drawback could be good if the company wants to maximize the amount of fairness in its team color competition, but it could also be bad if the specified company wants to maximize the people from different departments getting to know each other. The age distribution for this weight is also roughly similar, which is a good thing. Now, the people in each group are exactly the same, which is required for the team color activity. And so that was it for the model that prefers the gender. Now let's just explain a little bit about what the code is very quickly. So the first thing that you will see here is the preset weights, as you will see in the main.py file. In here, it tells you all about the weight of the program. So as you can see, for the preferred department, we have the weight for the department very, very high, and the next one is the weight that prefers equal people, while the gender weight is 0 here. And the age and the BMI is the weight that is least powerful in this case. So moving on, this is some streamlit specific configuration that just makes the web page look more beautiful. But the function that we all should be looking at here would be in the genetic algorithm. But before we get there, let's take a look at the data processing file. So in order to speed up our calculations, I've created this memoize class, which all it does is simply just remember the function return values in order to speed up some class processing. For example, the get central tendency is called a lot of times with the same value, so memoizing it will result in better performance. And these are also some code which detail the splitting statistics and is used later in order to calculate all those beautiful graphs that you see in the app. Now let's take a look at the genetic algorithm itself. Within the genetic algorithm file, you'll first find the fitness function and the run function. So first, let's take a look at the run function. So the run function first gets some basic data info from the data frame that is provided. So as you can see here, it gets just how many people there are, the gender, the departments, the weight, height, and age, and all that stuff. It also attempts now to generate a population and assign the people to either group 1 or group 2. So as you can see in this code, then it will run the genetic algorithm for a specified number of generations, calculate the fitness, and then proceed to rank it. And then for the reproduction, I chose to use both the crossover method as well as asexual reproduction. So the crossover method will run once every 3 times, while the asexual reproduction will run every time that the crossing reproduction isn't done. So now let's take a look at the fitness function. First of all, the fitness function then groups people into group 0 and group 1, and then it calculates the difference between the males in group 1 and the males in group 0. Then times them with the weight of the gender, and does the same for female. The next weight is going to be the department difference weight. So as you can see here, for each department, it will calculate the difference between the first department, the department in group 0 and the department in group 1. Now, since we want this weight to kind of make sense, the more people a department has, the more weight it also has, as you can see with this line of code. This number is then multiplied by the weight of the weights that can be configured in the hyperparameters. And the next weight here is going to be the BMI difference. So in here, we first calculate the BMI for each group, and then do some binning, and then subtract those binning to get the difference, and then apply a function along the axis in order to absolute those differences, and then sum those all together, and then multiply by the weight of the BMI. And the other one is going to be the age difference, which roughly does a similar thing to the BMI difference. So as you can see here, we first bin the age values into specific bins. So here 20, 30, 40, and 50. And then multiply that value by the weights. Now, the last special value here is going to be the equal people. So this value is used by the preferred departments, one where it doesn't specify the gender, but it wants the people to be equal. So the way this works is just minusing or subtracting the amount of people in group 1 and the amount of people in group 2, and then multiply by those weights. At the end of this fitness function, we then calculate the total score here and return it. So this is it for the code. Thank you. So now let's summarize which model that I would prefer to use. Between the preferred gender and preferred department models, I would choose to use the preferred department model. Why? Because the purpose commonly for organizing a team color game is to ensure that the people within the organization from different departments get to know each other. Now, while there may be some compromises, such as compromisation in gender, and there may be some concerns to fairness, most of the team color activities that happen in organizations are to have fun and promote relationships. Therefore, looking at the graphs from the preferred department's weights, we can see that this would best suit many companies. So, to summarize, I would prefer to use the preferred department weights. So that was all that I had, so thank you very much for watching.